Hey guys, so I'm gonna split up my video lectures on exponential growth and decay into three hopefully short videos. So for the first one, I want to talk about a particular example that shows up on our homework in exponential growth and decay, where there's a problem in which it says something about the slope of the tangent line equals some number times the y coordinate. So this is one of the problems that shows up on the homework. So to start this off, I want to start off with a question. So the question is, I want to let y equal e to the 3x. And then I want to ask, what is the derivative? What is dy dx? Okay, so I want to take the derivative of this. So to take the derivative of this, I got e to the something. I want to recall how to take the derivative of something like that. So remember that if I want to take the derivative of e to the x, that's just e to the x. And if the exponent is more complicated, so if the exponent isn't just x, if it's more complicated, if I have e to the stuff, then there's a chain rule step. So the derivative there starts off as e to the stuff, but I multiply that by the derivative of the stuff. So for our problem here, we don't just have e to the x. Our exponent is more complicated. We have e to the stuff. So to take the derivative of that, the derivative of e to the stuff starts off as e to the stuff. So I'll get e to the 3x. I get e to the stuff. But then I need to multiply by the derivative of the stuff. So I need to multiply by the derivative of 3x. Okay, so we know what the derivative of 3x is. So this e to the 3x is still there. And I know that the derivative of 3x is 3. Okay, so that's dy dx right there. dy dx is e to the 3x times 3. Okay, so one thing that I want to point out is notice that when we took the derivative, e to the 3x, which was y, is showing up in this. So another way that we could write this is I could write dy dx, and dy dx is 3 times e to the 3x. So I could write y for that. E to the 3x, that was the same thing as y. And then, I know that the derivative is the slope of the tangent line. So the left-hand side is the slope of the tangent line. So the left-hand side is the slope of the tangent line. So what this is saying is the slope of the tangent line equals 3 times the y coordinate, or the y value. Okay, so for this function that we started off with e to the 3x. When we took the derivative of that, what we found was that the slope of the tangent line, the derivative, equaled 3 times the y coordinate. Okay, so it turns out that this type of thing, like when the slope of the tangent line equals some number times the y coordinate, it happens only when our function is an exponential function like this. So I want to write that down next. Okay. All right, so if the slope of the tangent line to the graph of a function, I'm going to say of y equals f of x, to the graph of y equals f of x, at any point is k times, so k is going to be some number, is k times the y coordinate okay, it's k times the y coordinate. It turns out, so it can be shown that our function was an exponential function. So it has a general form. It can be shown that f of x, it had to look like something of the following form. It has to equal c, where c is going to be some constant, times e to the kx. Okay, so it turns out that whenever the slope of the tangent line to the graph of my function at any point is k times, so k is some number, k times the y coordinate, our function f of x has this form, where we might have a constant in front, and then times e to the kx. Okay. Alright, so I want to use this idea to look at an example. So the example that I want to look at is really similar to one of our homework problems here. Okay, so the example is this one, number 1. It says the graph of a function y equals g of x, so I'm calling it g of x here, passes through the point 0, 8. Suppose the slope of the tangent line to the graph of y equals g of x at any point is 5 times the y coordinate. And then I want to find g of negative 3. Okay. Okay, so what this is saying is, this is saying that the slope of the tangent line, equals 5 times the y coordinate. So this should be 5 times something, and it's 5 times the y coordinate. So 5 times the y coordinate. Okay. So this equation right here says the slope of the tangent line equals 5 times the y coordinate. That's saying basically the same thing that this remark up here said. This remark said if the slope of the tangent line to the graph is k times the y coordinate, then the function looks like this. It's some exponential function that has this form. Okay, so for our problem, our function g of x is going to have this exponential form, except for us, since it was 5 times the y coordinate, our k value is going to be 5. So in our problem, k is going to equal 5. Okay. All right, so for our problem, one sec. So in our problem, we get that g of x, because our function is g of x and not f of x, has this form. It's going to have the form c, some constant, times e to the, and then our k value is 5, c times e to the 5x. So our function g of x is going to look like this. Okay. So we need to figure out what c is. So to do that, let's use this given piece of information that they told us. They told us that our function passes through the point 0, 8. So what that means is, if I plug in 0 into my function, well, if I do that, what I get is I get c times e to the 5 times 0, which is 0 on the exponent. This should equal 8. So when I plug in 0 to my function, I'm supposed to get 8 out. Okay, so now simplifying this, e to the 0 is 1. So this is just c, and I get c equals 8. Okay, so now I know what c is. Now that we know what c is, we can go ahead and plug that back in. So we get g of x equals 8 times e to the 5x. So now we know what our function g of x is. It's 8 times e to the 5x. And what we wanted to know is, what is g of negative 3? So to find g of negative 3, I just plug in negative 3 in for x. Alright, so if we plug in negative 3 in for x, we get 8 times e to the, and plug in a negative 3, my exponent is negative 15. And then that's my answer. So g of negative 3 ends up equaling this. Okay, So that's the idea for how we do an example like this.